specifically governance designed from first principles for a specific task. So conviction voting is probably, I would just want to start off by saying it's probably not the only kind of governance method that we use. There would still be, like for upgrading a system, you wouldn't use conviction voting. You'd use the normal token weighted, proposal based system, yes, no. So you'd have that normal DAO structure, but when you're trying to allocate funds, it's a specific task. And voter apathy is too high. If you have somebody who's asking for $1,000, no one's going to vote on it because it's yes, no, and no one really cares. And the people that do vote on it, it can be biased, it can have problems.
Well, if we look at current on-chain voting right now, there's very, very small people paying attention. There's not a lot of, the due diligence isn't going into the voting process. It's too clunky a voting process. So we've realized that on-chain voting has some issues.
Yeah, and so conviction voting aims to solve that and other issues that we've seen in TCRs because there is a decent amount of experience in TCRs that we can look to and simplify that system so that we can implement something that will fight voter apathy, make good decisions, and actually flow into the rest of our system as well. Because it's not just conviction voting. We know we have a bonding curve, and we know we have the give it that coming at the end. So we can design conviction voting with those assumptions. So of course, just as a baseline, the bonding curve has tokens, and the tokens, the bonding curve token, the commons token, is what allows you to vote in conviction voting. And you're voting on proposals that are made in the give it that. So there will be a nomination process, which I don't think I need to go into, but you can just assume that not every proposal that's made on the give it that all of a sudden shows up in conviction voting. There's a way to nominate proposals in the give it that so that they can be voted on, basically. Now, within conviction voting, we have users, people who hold tokens, and we have the proposals that they can vote on. And we have the funding pool that is used to send money to those proposals. So there is a basic kind of one person, one token, one vote, but voting power is not just dependent on how many tokens you have. It's also depending on the conviction. So there's effectively a time component. So if you have conviction adds up in a really interesting way. And I think that's probably like the best way to show it is kind of this graphical interface. But it's also really easy to show with math, right? Because it's a very simple equation. So your voting power is the number of tokens you have times, the amount of conviction that was there before. So calling Y star is conviction, right? So Y star T minus 1 and plus the number of tokens that are for choice C. So like if there's one proposal here, multiple people might be voting for it, right? And having saying, hey, I like this idea. I want to allocate a percentage of my votes, my voting power to this. And so that would be this. This is the total number of tokens at time t, right? And then you take the total amount of conviction that you had before, and let's say it starts at 0 because this idea was just proposed, no one had voted on it, and then you multiply it by alpha, which is what we call a forgetting factor, right? So if there's 10 tokens voting behind it, maybe 7 from one person, 3 from another, they both vote on it on the first moment that it pops up, boom, there's a conviction of 10, right? Because it's 0. So now Y star, if we go to the next one, let's say alpha is 0.9, because that's actually an alpha that we would like to use. Now we have 0.9 times 10 plus 10. So it goes from 10 to 19. And then we have 19 times 0.9 plus 10, because no one else has voted on it, right? And so now we have somewhere like 28.8 or something like that.
So essentially, it comes out in a curve like this. Yeah. So your conviction grows to a certain point, and when you actually I think is my screen still shared. So on the screen here you can see each proposal is like a bucket, and you have a preference faucet. So as a voter, you are a faucet, and you are allocating your preference into these buckets, and these buckets are filling up. And when you move your preference somewhere else, you don't just bring your preference with you. It's like it's biomimetic. So the preference drains from the bucket, and your preference fills in the new bucket. So why do we do this? Because we have an issue right now with on-chain voting with token volatility. If a whale can take 100,000 tokens, because it's one token, one vote, and dumps 100,000 tokens on the yes, then all of a sudden it's a yes vote. So and they can come in at the very last minute because the proposal is live or the votes happen from Wednesday to Saturday, and he comes in on Friday night and says, everybody else wants no. Well, 100,000 tokens on yes, too bad, I decide. This is plutocracy, and this is bad. So if we introduce these token dynamics where the buckets fill up and the buckets drain, then you can't just fill a bucket immediately. It has to gain weight and lose weight according to biomimetic properties. So this is how we can address plutocracy in some ways in on-chain voting.
It very little. Yeah, so if you have a high alpha, it takes about 30 days to get to the 30 time units, we'll just say days, to get to the full weight. So you'll end up with, if you have 100,000 votes, you put, tokens, you put those 100,000 tokens in, it'll be worth $1 million in 30 days. And so because of this gradual increase, you have a lot of time for people to see where the voting power is going. So people can understand, okay, this is where the tokens are now. We can see if nothing happens in 30 days, this is what will happen. So now we can see, oh wow, this whale just put a bunch of money behind this proposal. That proposal looks like a bad idea. I better sell my tokens and get out.
Just one question to be clear. What's the condition for a proposal to pass? It's just that it arrives at a specific time, at any time. It needs to be a point during some time. What are the rules, more or less, for the?
So we call this the trigger function.
Yeah,
it's a threshold set by the community according to what it needs to be. Because we're designing the system for anybody, we don't say what the threshold is. I mean, when we use it for a specific purpose, you set a threshold over which proposals pass, granted or given that they've been live for 7 days. So these all different colors are different proposals. Again, on the screen, you can see
thresholds that vary based on the amount that's being requested.
This trigger is average.
So the trigger function looks like this. So where this is the amount of conviction required, right? And there's a minimum conviction required that is set. And then the bottom axis is actually the amount of XDAI being asked for over the amount of XDAI in the funding pool. So the percentage of funds being requested. So if you're asking for a very small amount of funds, and it's like 0.001% of the total money in the pot, you still have to meet this minimum conviction requirement. Sorry, it ends up being negative because this is a log function. But so this is kind of like a minimum quorum, you could see it as. And then there's also a maximum amount that can ever be requested.
It's a total pot.
Yeah, so the total pot might be, $1 million.
20%.
But yeah, beta might be 20% or 30. And this is like the most that you could ever get out. If you had all the tokens and you put it all behind the thing and you waited for your conviction to max out, you'd only ever be able to get 20% of the total pot. And so what we have is a minimum quorum and we have a varying amount of conviction required based off of how much money you're actually asking for.
But the question was, so this trigger is just at the point that the total voting compensated with the timing.
If even for a moment it reaches, then it
That trigger,
Yeah.
that's free.
As long as it's been live for 7 days.
Yes. So
So there's also, it has to have been live, so you can't just say, okay, I propose and then I put my conviction and then it passes. It has to have a 7-day window.
So during 7 days, it needs to be over the trigger.
And 7 days is just,
Well,
it's just
after
a,
the 7-day point, if it crosses for even 1 second.
Okay,
right.
But if it crosses on the first day and it goes back down,
it doesn't go. So it's from the 7 day. I expect it's going to be a limit for the
So-
removing.
Zargam, do you have any thoughts on or details on the 7 day idea?
You're muted.
You're muted.
We cannot hear you.
Finding. Okay, I'm unmuted. So a couple things. One is that 7 days is just another parameter. We can set it. It's a rate limiter. So I picked one for that initial demo and I made it 7, but it's one of the parameters that we would want to test. So it says basically, because we don't want things to, again, we don't want someone to be able to shock the system to pass something immediately, even if they spend massive amounts of money. So we really want the fact that something's happening to have, to be visible. But that's a parameter. It's one of the many things we would want to test. The other thing is that even in this system where we're saying the hard max is to take 20%, if we look at the sensitivities, it's almost impossible to get anything more than like smaller percentages. But again, like if you set the parameter 20%, then it was like 5 to 10% that was actually reasonably feasible without like it getting so requiring almost unilateral support. And so we're basically saying that this constellation of parameters is going to define what can realistically happen, which brings us back to the need to do A/B testing and sensitivity testing. The behavior of the system is going to depend a lot on things like what these trigger functions are. And I threw in the Telegram some two pictures for Jeff to share. One is the heat map of the trigger function as an example, and the other is just like a single block of Python code that actually implements it's just exactly the code that makes the equation the heat maps from. So if you wanted to show those two, those might be a little more concrete for Jordi to sort of see what kind of thing we're proposing. But we're also not saying that there's one final answer. We're saying the trigger function is like a event thing. And when you decide what the event is, that is an important component of the system. And we think of it almost like a neuron firing. The idea is there's an action potential building up from the conviction, and that there's a condition that says when this action potential is achieved, a discrete event occurs. So we're transforming a noisy, decentralized, private signals, behavior, bullshitty thing, which is many people with lots of stuff, into a single discrete event. And so we're thinking of it almost more like a signal processing operator from time varying distributed into like one moment in time, one discrete event. And so the derivation comes from the idea that we want to do that efficiently, not necessarily from the practice of voting per se. It's that we have this massive behavior and opinion, and we want to convert it into an event.
Who can make proposals?
Anyone can make proposals. The question, because it's a give it system. But now when we have the give it system involved, we have campaigns that anyone can make a proposal, but then you have a campaign manager that will accept whether or not that proposal shows up under theirs. And then those proposals will have to be nominated. Now, exactly how we nominate it is still up for debate. I'd also say that 7-day trigger and many of these design functions, the exact parameters, this is why we have CAD-CAD. It's a complex system, and we're definitely going to like inch with them, but I would assume that to nominate a proposal, you have to stake some number of tokens behind that proposal, and it has to stay there for that time period of 7 days.
Just my feeling, but that's maybe I'm wrong there, and there is also this timing parameter in there. But my feeling is that this trigger, I will not do it in a single point. I probably would do it.
It has to stay above it for some amount of time.
That's, I would, even
Yeah.
if it's a short, but I would probably feel more comfortable on that line.
what that actually means.
Yeah.
I know that there is this this filter, this time with this time function, this does not allow to change very much. So I don't think it's even possible for that. But in my mind, I would say it's like peak can be easy, just maintaining can be more even. So I would just think
like maybe instead of the 7 days before it votes, maybe it has to be above the trigger for 7 days.
Yeah,
right?
or something like that.
Or at least
Or 1 day at least.
or 1 day, yeah.
The design space on these are very open.
Yes,
This is
that's,
just like the very
it's just a
first
feeling, but
step.
I'm not even sure. You can simulate that. The nice thing of this is that you can simulate this kind of stories, which is cool. I'm a little afraid here for the proposing. These proposals. There is a lot of attacks. So for me, the problem is the relationship between proposals. Proposal is when we are talking one proposal, it's very easy. We do it or not. Okay. But sometimes there are proposals that are dependent on each other. If we do this makes no sense to do this. And if we do this, I want to do this. But if we don't do it, this is absolutely, this kind of dependent, or proposals that are similar.
So this is really interesting actually, because this is actually built into the model as well. So you have a graph of participants, and you also have a graph of proposals. And the edges in these graphs between participants, it's influence. So your decision may influence mine. And the edge between proposals is competition. So you can model similar
and there is even attacks there. I can put, similar proposals, maybe changing something that makes them better, but actually are competing with other proposals. And then all this conviction voting, you split the vote, and it's a way for attacking, going against a proposal. That's the kind of things that blows my mind in here. So I don't know how this is solved on
The cool thing is we can build it into the model and simulate for that. Can you turn that screen to Jordi? So this is a graph of all the participants in the network.
That's really cool. But this is, it's like maybe. I think you're getting it. So this is great. The thing is that when you're designing something like that, you need to think on that. And then once you more or less have the idea, then you simulate and do it, which is cool. It's perfect because it's something that looks better, but then you put it there and this will not work. Or maybe you have to change some other parameters, so you have to design. But
So the point here, Jordi, is actually not that we know, it's that we have the tools to test. So the reason why the concept of model of proposal conflict is actually already in my model. So there's essentially, it's a multi-graph. One node type is participants and one node type is proposal. And there are proposal to proposal edges. And those edges have a variable called conflict. And that conflict is again, obviously this is modeled, is a measure of the phenomenon you're describing precisely so that we can run experiments that say, if there's high degrees of conflict, what's it break down? What goes wrong? And then we can start to ask about how to fix it and try to change the algorithms based on our understanding that, oh, we have a failure mode if there's high degrees of conflict. Or maybe if we come up with a solution, we can show how resistant it is to that type of attack by saying, hey, thanks to this change in this algorithm, now the system is, gummed up less when people do that. You see what I mean?
Yeah, I was thinking more. You're facing the problem by the way that by the parameters that the current system is built. I'm not sure if it's a good idea having like a previous stage. Before a proposal gets to be voted. It's like trying to be like a previous stage where you sort these proposals. Where you put down some
grooming process.
Well, this is in the give it dap, right? Yeah. So like the give it dap, there's the proposals, which currently we call milestones, but then there's campaigns. And so a campaign manager will say, yeah, this is a proposal I want in my campaign. And which campaigns are allowed to be part of conviction voting, that might be a parameter that, this is a certified campaign. We know this campaign manager. Maybe there's like not a conviction voting process, but another DAO voting process to say, this is an authorized campaign that we can accept proposals. Because it's very important that anyone can propose an idea. But it's also important that we have filters before those ideas come to vote, right? This is like the initiative process in a normal government. You have to go get 50 signatures.
Three persons, you mentioned that at the same time appear 3 proposals that are almost the same.
Yeah.
And I'm not saying the same, I'm saying almost the same, just to be clear that it's like, and it could be even a competition, you know, it's like, we're the same, but you know, it's like mine is red and this is blue. We are both going to build a building, but this is, I want a blue building and a red building.
Yeah.
And maybe the voter is, I just want a building. I don't care if it's blue or red, you know,
Yeah.
I just want a building.
Yeah.
So how we solve this kind of issues, you know, is maybe it's a sort, okay, let's do first, if you want a building, and then we do like a second voting, is to see if it's blue or red, you know, it's
Yeah.
like, but you need to reorganize the decision making because, you know, the proposals are dependent, you know, are the same proposal in this case, but are the, or I want to build, or maybe you want to be, I want to build, you know, a nice coffee room for this building, but you know, you will not be able to run a coffee room for the building if you not build the building first.
Yeah.
So it's like voting this, you know, it's like
one of the problems we're getting into now, though, is we're talking about it as if this system is going to replace the political human workflows. They don't go away. We're facilitating discussions. We're making things more transparent. But at the end of the day, no algorithm, like people finding their preferences and moving, like we're not trying to like do it for them. We're trying to make it easier for them to converge. And so I actually just sent another thing in the Telegram that Jeff can share if he decides it's useful, that talks a little bit more about the hierarchy from wet discretionary decisions all the way down to like, you know, the sort of dry automated decisions, and the fact that it's not just, you know, it's not just automation and governance. There's sort of a continuum of things that are more open-ended human, social, political towards things that are all the way down to this is exactly how it works. And what we're not trying to do is magic everything into automation. We're trying to make tools that facilitate the human process. And so good algorithms aren't algorithms that do it for you. They're ones that facilitate a convergent process to a decision. So the health metrics of the system are not like just like, hey, did the votes pass necessarily? They're actually about the ability of people to coordinate, reallocate, and decide. So we are making it visible, for example, that if 3 proposals are very similar and none of them are getting enough conviction to pass, the fact that that's the case is visible. Furthermore, it's visible to say, hey, you know, if actually, you know, 50% of the people from A and B all moved their weight behind C, actually C would pass. Like A and B would basically be dead, and then it might end up getting all of their support pulled because C passed. But like, you don't just have the notion that you don't just have the notion of what people want. You have the dynamics of the convergence process of agreement made more transparent, so that if someone is actually just stymieing, that's actually somewhat visible. And so,
wait, so Jordi has a question.
Yeah, the thing is that just to for this is, for example, in the political way to solve this is that it's like there is like a voting of what you are going to vote. It's like when you know, so it's like and in general. Deciding what we have to vote, you do that because it's much easier to reach a consensus.
Yeah.
On that.
And we're not excluding that, we're just not focusing on it. And so when Griff keeps bringing up GiveF, we're basically saying we can add other layers if we need to, but we also have to be modular and sort of MVP oriented. So our novel element is for these smallish communities, and if we need to add a layer, it's strictly composable. We can say the only way to get on the proposal list is to follow another process.
Yeah, okay, that's good. Okay, just go ahead, just move.
Yeah, so, I mean, as he said, I think it's very important that conviction voting is is the like final vote. It's like point voting, but there's always going to be these like Telegram groups, or maybe it's a Slack or whatever, where people actually debate. Just like in Mullik right now, like hardly anyone actually votes. It's really pathetic. But with this system, what's really nice is that we're going to focus on making it easy for people to be able to vote. I'm really excited about ERC 888 and the different abilities that we can have to make it so that you can constantly signal preferences, so that when you have tokens in your wallet, you might have a balance, right, of let's say 10 tokens, and you've already decided to signal your preferences to a few things. Well, now let's say that you decide you love what's going on and you want to get more tokens. So now you actually buy another 100 tokens. You don't have to revote. You shouldn't have to revote. The fact that you just got new tokens should be already accounted, should be calculated in, and those new tokens can now be added into the system. Because instead of a system that's like very time bound, where there's only, you have to vote from, for during this 5-day period, and the number of tokens you had at the beginning is all and now you have this required action.
But you start, the timeline starts, huh?
Yeah, when you start.
When you buy 100 more, then this 100 starts grilling. It's like you have 2 accounts. It's not, the others may count a lot, so the other 10 may count more than the 100 at the beginning, not at the end.
Exactly.
I expect it should be this.
Exactly.
Your curve parameters.
Yeah.
No, it's exactly that. And this this also means that you can vote once a month, and you can change your balance. You can do whatever. Or you can vote erratically, independent of what's going on in the outside world. It only matters what's going on in your world.
This is just 2 things. One, you already know, I'm a big fan of liquid democracy. I think that this is good, but this does not replace the liquid democracy.
Definitely not.
I think they are solving
Delegation.
two different problems.
We can add on liquid
You can add
democracy.
on that, but I think it's
Yeah,
important.
also a big fan. I'm with you, Jordi. I think that in order to actually have this work in the long term, you'll probably end up with people having delegation logics where you just streamline the ability to say, hey, I'm doing this and I'm going to allocate my holdings in a certain way. And if you say support my position or my opinions, then you delegate to me and essentially mimic my voting distribution. And we can find ways to create that feature functionality, but I think it's something that we can watch the liquid democracy world continue to mature, and we can adopt best practices in a composable way.
You can ask to a person to be responsible, to delegate their votes to the right person, but you can ask to the people to analyze each decision you want to make and to do that. And this is, I think, that's something that's very important on any decentralized system and we need to understand. So that's why I'm a big fan of liquid democracy, and it's an important piece, even if you are designing systems.
I view these as completely complementary, that in a sense that this framework that we're proposing allows you to aggregate information. You could even, if you're using a delegation scheme, I could even say that my choice is actually just, I distribute my votes at 10% of Griff and 20% of Bernd and 70% of Jordi, and I could get a well-defined distribution under my conviction voting model, actually just by saying that my position is X% each of these other delegates even. And that could be something that doesn't even require anything other than looking up the state of that person's votes.
Yeah, and the other thing that I want to mention that I think it adds a little bit of complexity, but it's very exciting, is all the quadratic voting. Here is here I understand that you are doing one token, one vote, and you can allocate as you want, but penalizing concentration, I think is an interesting topic. There is a lot written on the topic.
But it needs identity.
It needs identity.
It needs identity. Also, it's also complementary, strictly speaking, because we're dealing with space or dealing with time, and that deals with space. And so you can actually do both together and again, we need to use analysis to understand what that will mean systemically. But strictly speaking, there is nothing stopping us from imposing both the temporal integrators of conviction voting and the spatial distribution logic of a convex voting algorithm. So even quadratic voting is just like, it's the simplest version of a diminishing returns on voting scale. And so there's actually an entire class of algorithms that go beyond just saying quadratic. So, you know, what we want to be able to do is explore the space of the time integrals from conviction, the spatial distributions from convexity and diminishing returns, and the distributions from liquid democracy. And this actually kind of goes back to the whole point about CAD. It's that we know that we don't know what will happen when we start mixing these things, and we want the ability to play test them before we put them into real human processes.
Yeah, it'll be so cool to have all of this mapped out in CAD and have them be separate modules that we can plug and play. It really wouldn't be so hard for us to implement a quadratic voting system on top of this, especially because in the hatch, we do KYC and we do have basically a centralized identity oracle for the hatch system. And then, but on the open system, we want it to be permissionless. And so if we had a Bright ID thing, or we had some sort of opt-in, if you want more voting power, give us your identity, and then, you know, quadratic voting could apply. Otherwise, you're penalized, right, if you don't. There are cool opportunities, but it's scope creep. It gets to be scope creep, right? Like, we don't want to, we want to be good at a couple things, not like trying
Yeah,
to.
that's probably for a second version. Just for quadratic voting, for example, from the parametrics things, I would like, we always talk about it's a square. So lots of time it's quadratic because maybe what you do is you do the square root of the voting that you are assigning. I would like to play maybe with, I don't know, what happens if you do something that's 0 to 9. You know, just I would like to play this kind of. It's not from going from linear to quadratic, you know, with some gradient there. That's interesting.
And what they call quadratic voting is actually the square root function. I think they just call it quadratic because they're dealing in narrative space. The mathematics that they're actually using for the thing quadratic voting is that you get the square of your you get the square, which actually means any any concave function, and in anything with power less than 1 is concave.
Okay, wait. I wanna get off quadratic voting because it doesn't apply, and I actually want to jump.
I'm just saying, I agree with you.
I want to jump into something a little really important that we can't miss before we go. So it's really, how does conviction voting and CAD, because we didn't do it for CAD, how do they evolve through our iterations? So I'm just gonna do, maybe Jeff, you can do the whiteboard. But in our first iteration, CAD becomes an open source system, and we greatly improved the documentation. As far as our DAO, it's completely basic. So CAD it gets like kickstarted iteration 1. The DAO, completely off the shelf Argon DAO. We don't change a thing. We don't audit a thing. We really are focusing only on the bonding curve. And then if we raise enough money to do iteration 2, then we do make some major advances in CAD, specifically on showing people how to use it, right? We throw down $50K into building at least 8 videos, including tutorials and assignments on how to use CAD to make it effective. Basically a graduate level online course. But again, for the DAO, we do almost nothing. We will maybe upgrade based off of what upgrades have been done with whatever DAO framework we're using, but it's not something that we would need to audit at all. Because again, the second iteration is just for the give a DApp, where we really focus on interoperability and escrow and transparency coming out the back end for payments. Now, iteration 3 is where we actually start doing conviction voting. And it's a huge undertaking. We will have most of the features that we talked about. We will make sure that we have block science doing extreme CAD modeling, parameterization. We will have the continuous voting and continuous preference signaling. With also, one thing we forgot to mention is explicitly it's continuous liquidity. Basically, even though you're voting with 100%, at any time you can sell all of your tokens. You're not locked in at all. We'll also be, of course, doing the classic like conviction building up over time with the trigger function. All of that will be integrated into the Give It DApp, where the proposal Give It DApp will be the proposal framework for the DApp, but we will not have delegations. Delegations will happen in the next iteration. And for CAD, we'll add an extra developer to the CAD so that we can really take all the lessons that we've learned from the previous 2 iterations and fix bugs and double down. So because iteration 3, we really focus on conviction voting, so we don't put too much focus on the other aspects, including CAD. Now, iteration 4, this is where in conviction voting we actually start to add delegation. That's the very first like upgrade. And I don't know how liquid it will be. It'll be whatever we can. It might just be 1 delegation. It's really hard to say, as when we start getting in iteration 4 territory, this is 2 years down the line potentially, right? Like there's a lot of this stuff may already exist and we can integrate and move better than we can. Although if it doesn't, then we will make sure that we have at least 1 hop delegation, ideally more. And CAD gets a nice push here in iteration 4, where we actually publish a basic token network module. So we will have models for everything we're doing, right? Conviction voting, the bonding curves, the Give It DApp will have sort of a model, and we'll have a full system model. But once we hit the iteration 4, we start building CAD modules so that people can start with the base. If you want to create a token network, every token network will have these same needs. And so we can basically give you, just like if you wanted to, like when I'm using AutoCAD for my Burning Man camp layout, right? I can take the old layout, move things around, and it's so much faster than starting from scratch. This is where the token network module is the same thing. Here's this like baseline, like an ERC20 simulation. And now you can just change the couple things that you want to change, and you can see how does that affect the design, right? And this is iteration 4. And then iteration 5, we do the same thing, but for token bonding curve. So we take our model that we made with our specific augmented bonding curve, and we retrofit it to be a token bonding curve module. So anyone can start with a really clean slate, lots of documentation on what they need to change and what options they have, and then they can take that and run with it. And so we can see a lot more experimentation with token bonding curves, and like robust engineering style experimentation. Whereas conviction voting, we add an online course so that people can see how to use conviction voting. In iteration 5. And we do mobile first, which is of course, that's the whole point of iteration 5, is to do a full UX audit, like make it so that you can do conviction voting on your phone. But also, I think it's really important that we start, doing a lot of video models for everything. While we're doing mobile first, we're also doing conviction voting online course. Yeah, of how to use conviction voting, and the model, specifically the design model, so that if other people want to implement conviction voting, the CAD conviction voting CAD model, and then we go to iteration 6, where we do a DAO, a basic DAO CAD model. So simple governance module, sorry. So lots of documentation, lots of all of this jazz, right? So that people can actually take this baseline CAD DAO module and integrate their own ideas on top of it. And then for conviction voting, you know, again, all of these, every iteration, we're obviously going to be doing bug fixes and the normal GitHub like improvements and taking in user stories that we've implemented, fixing the you know, the design. If things need to be redesigned, then we will redesign them in CAD and implement with what we've learned. But the real goal here is like when we're doing conviction voting, this is all a very basic, like standalone smart contract. For the 6th iteration, we hope to actually make it a module, like kind of like an Argon app, if that's the direction that we're going, so that it can be really easy for other people to just like plug it in. So just like phone apps, you know, Argon is the furthest ahead right now as a platform for you know, just being able to start up your own organization, your own blockchain-based organization. We want to make sure that conviction voting can plug into the bonding curve and all these other options so that anyone can easily deploy it. And also our front end would be an option for anyone. So it's like taking all of the code and everything we have and making it so easy that anyone could just go to, like, spend a day and they would have an ecosystem that has conviction voting, plus the bonding curve, plus the Give It DApp integration, plus nice mobile applicable UIs, and all of these pieces within about a day's worth of dev work. That's really the dream. I know it's a tough dream, but this is also, you know, time-wise, this is 3+ years down the road. So, you know, that's hopefully we will learn a lot by then, and we'll have a really robust system that people can use. So yeah, that's kind of the idea of roadmap. Obviously, each iteration will have audits on any smart contract changes, and there's a lot of other basic things that happen each iteration, but I think those are the highlights. What do you think, Jordy?
I would say the first ones are more or less clear.
Yeah.
When you start in the 3rd, 4th, it's too long for me.
Yeah. And I was hoping I should have done this iteration part for CAD during CAD and not be integrating that in. But like for conviction voting, it starts in iteration 3. First ones are just basic DAOs. Iteration 4, we add, you know, liquid democracy, hopefully at least 1 hop delegation. Iteration 5, we make it so that we make it mobile first, and then we make it really easy for people to play with the CAD model. So like if someone else wants to integrate conviction voting, they have this, like, this is how you use our CAD model. Now integrate conviction voting.
If you tell me this roadmap as the idea, as an initial idea of what you want to do, and it's just to have a roadmap and, you know, not get lost, I think it's fine. If you have to stick to this,
it'll change
for sure. You know, it's like I have no doubt that you will have to change. The problem here, you see that, you know, you have like 2-3 products that you are putting in the same roadmap. Probably makes sense to have different roadmaps. I know that you have to put it in this way. Yeah? I'm not saying you have to change it. It's good to have in this in the same phase, especially when you're asking money for.
Yeah.
But
no, we need a roadmap for bonding curve.
Each one will have a specific one, and it may not go at the same piece. But it is good because at least you have a priority. Now I see that, for example, liquid democracy is just before so it just goes after the conviction voting, which is but yeah, you need voting. So yeah, that makes sense.
And who knows? You know, maybe Argon integrates liquid democracy in a year, and we can have it before conviction voting.
And for
it's
me,
possible.
Something that sounds me strange, you know, it may happen, but sounds me strange is when you want to set up these toolkits where you can build, which is good as what you really want to build, which is good. it's difficult to think, at least in my mindset, it's difficult to think in a toolkit when you building a toolkit when you have not built the first.
Yeah.
That's something that it's difficult for me, at least, to. It's like I don't even want to talk about the toolkit before we don't get the first. Once we have the first, and we see if this is more or less suitable, and I would say not even the first. When you have built 2, 3, 4, you understand how the system works, then you may start thinking of that. But that's more, I would say, that's more in my
Yeah, no, but that's not wrong. But there's a challenge where, at some level, if one of your main priorities is interoperability, then you have to go a step higher in abstraction in your original design. Because if you build a one-off that doesn't have the right like systematic elements, then your things don't become interoperable. So it forces us to do it harder. But you're right, it is harder to start up one level.
Yeah, it's you said the word. It's like you need to do this level of abstraction that for me is hard to do from the executive part. Okay, but I agree that's interesting exercise to do it, and I think it's also interesting in order to sell the product. It's like where at the end, especially the last one, is what's my vision? What I want to build. What's my future? So this makes a lot of sense, and maybe what you want is this to automate the way of these non-profit DAOs or whatever organizations, and then you want to put it in there to be automated, and that you can facilitate the way of doing that. You want to build them. So it makes a lot of sense from the vision perspective.
In a dream world, it'd be easier to set up a token bonding curve based economy with conviction voting and all of this than a nonprofit foundation, right? Like that's the dream. Hiring a dev for a day or two to like hack on this and just like crank it out should be easier than starting a foundation.
That's a good vision, but it's just a vision.
It's just a vision, but it's definitely the goal. And if I definitely worry about overcommitting on these last two iterations, because for each one up here, it's so clear. The first 4 are very clear. We add analytics in iteration 4. It's the fourth component to really get feedback.
Let's revisit though the fact that even though we've stated this and they all seem like they're at the same level, we've actually defined even the fundraising roadmap in campaigns. So each one of the iterations is the sooner ones are better defined. It's natural that the certainty level of the further out ones is lower, but we're also not actually asking for the money all at once. We're actually raising it in blocks. And so that same thing we were going over yesterday that Jeff has the notes on, and I think we'll probably end up discussing in a later meeting this week, goes over the idea that we're actually raising and committing to this tier-wise, meaning that we won't have raised or be making commitments to tiers 4, 5, and 6 anytime soon, most likely. And so there'll be room for us to continue to take advantage of new learnings and possibly refactor some of these roadmaps. And the only moment when it starts to be really problematic is when we are actually opening and closing a campaign associated with a specific tier of deliverables.
Are you the way that you want to raise? You want to scroll this money, I expect. So it's like you raise as much as you can, but you scroll, and then it's like a milestone that money is released at the point that it is.
So we're not completely escrowing it. We're not saying that it is basically still the multi-sig style, right? Where we have a clear roadmap and we have a clear budget defined. And very well defined. I think better than almost any ICO I've ever seen.
This makes a lot of sense. I know, well, except for ICOs.
Yeah.
The ICOs, I think they side.
I mean, in the end, if we need to grab into some of that budget to complete the iterations that we need,
for a scroll, I think it probably will need some more detail, especially in the next scrolls. It's like a more detailed roadmap on that.
Yeah,
it's like, well, there's this different models in investing in general. It's like kind of control for the investment perspective. If you are asking me from the investor perspective, I want to be absolutely screwed. I want to risk as less money.
Of course.
So I want to be sure that the money that I put is spent in the right way. So I want to know.
In-
If you're asking from the project perspective, I don't want that every step that I do, I need to give a explanation to be approved in something like that. So that's
yeah.
So
No.
let me share real quick before I have to go in 3 minutes, but I wanted to just show you what we worked on in one of our calm sessions earlier, as I actually took your spreadsheet and dropped it into a rough this JSON object, basically, well, it's a dictionary, and showed basically first that we could define this simply as each iteration, min raise, max raise, cutoff date, and expected time, and we'd even be able to sort of show that, you know, when we're raising funds over time, it's a slightly more sophisticated escrowing process, but it just basically says as we raise, if the current campaign cap is reached, then we start the next one, we close that one out, and we can be working on the work committed, and then it starts the new one. But there's sort of a logic related to minimums and maximums for each tranche and sort of what commitments are made. And I would generally suppose that we aren't actually making the commitments to deliver until we start the tranche that we're raising. So it gives us the ability to waterfall through this as a way of saying, well, if it's a year from now that we actually start, you know, actually collecting money for tranche 4, for campaign 4, then that's the point at which we have to be more concrete about what's in 4, even if it ends up being a little bit different than what we described today.
that's just working. Working.
Yeah. So, but we're working on even being able to show that in like a GIF so that people understand that this is a long-term iterative process, both from a scoping and fundraising perspective, and that we should always be pretty sure about, you know, the 1 or 2 right in front of us, and that the level of detail the further out is always going to be less certain.
Yeah, I mean, we have way too much detail in our accounting, honestly, like about how much we're going to spend for each phase, and like basically adding all of that to get the tranches plus a healthy buffer. But part of this design is such that if we raise, you know, somewhere between less than 984,000 to 1.71 million, we'll have this extra buffer of that amount that we raised to be able to complete this iteration, you know, because we only assume 10% buffer, which is not enough, but then we have this conditional buffer that's based off of if we raise extra money. So that's kind of how we're setting it up. But you know, yeah, when it gets to iteration 5 and 6, you know, things get fuzzier, but also the numbers get bigger, and we have much more buffer.
So you have to revisit this.
Yeah.
Many times I expect.
Yeah,
Even
for sure.
going perfectly. So, but that's good to have it. It's like important.
Yeah.
Sorry, man, but
No, hey, it was good. Thanks for coming by, Tori.
see you.
Yeah.
Okay.
Probably not.
You don't know, right?
Yeah.
Thanks, Charlie.
Thank you. I have to run to another meeting. Sorry, it's all over the place, but hopefully it's helpful.
See you, Z. Yeah, that was awesome.
Yeah. Thanks, Steve.
Thank you.
Cool. All right.
Tomorrow.